Good morning, guys. Today we're going to be covering Notes 2.06. This is part 2 of the notes from last time. And so the main goal in factoring is basically being able to identify, what situation we might have, okay? And so we've covered, different special situations like the difference of squares, the perfect square trinomial, and then the last lesson was the factoring trinomials in general, where you multiply the first and the last and see if you can find two numbers that add to the middle term, right? And so let's read this part here in the notes. It says, over the past couple of weeks, we have learned how to factor several different types of polynomials to become a master at factoring polynomials. It is important to follow these steps. First step, check to see, if you can find a GCF. That's always going to be your first step. No matter what problem you have, check to see if you can factor the GCF. And of course, if you have a GCF of 1, then you can go on and move on to the next step in the process. The second step is identify if you have a special situation, right? Do we have the difference of two squares? Do we have a perfect square trinomial? Or do we have a situation like what we covered in the last notes? Okay, so let's look at these three examples and let's see, can we identify what they are? So this first one, well, it has 3 terms, right? So it could be a perfect square trinomial because tri means 3. But we got to check, can I factor the first and the last? So let me zoom in here. But we got to check to see, can I factor x squared? Yes, right? Can I can I square root x squared? Can I square root 36? Yeah, that's 6. And then if this is my A and my B, what do I get if I multiply 2 times A times B? That's going to give me 2 times x times 6, and that gives me 12x. So does the middle term match? Yes. So that looks like I have a perfect square trinomial. So this is letter B. If we're matching, right? And then by process of elimination, right, we already used B as an answer. That means we're left with A and C. Remember, a difference of squares, if 2 squares means that it has a binomial. And we want to check, is there subtraction? Yes. Can I square root x squared? Yes. Can I square root 36? Yes. So this last choice looks like we have a difference of squares, so that means that 2 is C. And just to kind of cover what we did for number 2 is, there's a 1 here, and then we multiply 1 times 36. And so we're looking for multiplication and addition, and we want to say, negative 9 times negative 4 gives me positive 36, and negative 9 plus negative 4 gives me negative 13. So this was the method that we used in the last notes, right? And then the third step is basically what we were covering here. Apply the correct process to factor the polynomial. And on the next page, the processes are summarized. Okay, so let's go ahead and head over to the next page. And so in this page, we have the summary of the difference of squares, which is what we did. We square root the first and the last and check to see if there's subtraction. And then we use this as our formula. And then for a perfect square trinomial, let me zoom out a little bit here. A perfect square trinomial, we can have two situations. We can have a plus situation or a minus plus. And if we have a plus situation, that means we have two pluses in the parentheses. And if we have a minus plus, we have a minus in the parentheses. But we still have to check to see if we can square root the first term and the last term. For both cases, we have to make sure that the middle term is equal to 2 times a times b. We're going to keep practicing this process. And then the newest method is the one that we covered in the last lesson, where we multiply the first and the last number. And then we're looking for two numbers that multiply to get the first times the last. And then those two numbers add to get the middle. And then you set up your answer. Okay. So we're gonna practice that. So let me slide over to example 1. And of course, if we cannot do anything to it, then we call that example prime. But be careful, just because you can't see it right away doesn't mean that it's always going to be prime. Okay, so first thing, and for this first step, we have to remember from the very first notes of factoring that we had, we would try and find the GCF. And so is there a number that can divide all of these? Yes, they're all divisible by 5. Do they have any A's in common? Yeah, they have at least one A in common. So my GCF is 5A. So that means I'm going to divide these three terms by 5A. And then we would write the GCF outside and set up a parentheses. We would do 5 divided by 5 is 1. A to the third divided by A is A squared. Negative 10 divided by 5 is negative 2. A squared divided by A is A. And 5 divided by 5 is 1. A divided by A is 1. So I'm left with 1. Okay. Now, the next thing is, it says factor the polynomials completely. So what we have to do next is check and see it is, let me use a different color here. Okay, we want to check and see, is this a special product? Is it, is it a difference of squares? Is it something that we've seen before? And so we can check a couple things, right? Can I square root? Well, it might be a perfect square trinomial, but we gotta ask, can I square root the a squared and the 1? Because if we look at only the orange part, then the a squared is my first and the 1 is my last. Can I square root a squared? Yeah. Can I square root 1? Yeah. And if this is my a and this is my b, what's 2 times a times b? 2 times a times 1. That's 2a. So remember, we gotta ask ourselves, does it match the middle number? Yes. So we have a perfect square trinomial. And we have a minus plus situation. So we're going to set up, make sure the color is correct. So it's going to equal 2. We're going to set up 2 parentheses. And if I have a minus plus situation, remember that it should give us a minus b, a minus b. So if I replace the a and the b that I have here, it's going to be a minus 1, a minus 1. A minus 1, a minus 1. And remember, going back to what we just did, this is just the orange part. What we worked out here, this is just the orange part. And so if I box it up like this, then this is this part, right? But don't forget, what was in front of the orange part? The 5a, right? So in actuality, my final answer is 5a there. Is all of this. Okay, so let's recap, right? What we did is, first of all, we checked to see if the problem had a GCF. And it did. Everything was divisible by 5. Everything had at least one a. And so I divided by that GCF and I brought it outside. Then I checked to see what I had left over, the orange part, is this a special product? And so we did the test to see if it was a special product, and everything checked off, right? Check, check, check. We figured out that it was a perfect square trinomial. And so we say, oh, well, for that formula we use a minus b because we have a minus and a plus. So I did a minus b. And what did I put in the very, very front? The 5a. Okay. So let's go to the next one. And so, again, we got to check, is there a GCF? So here I'm going to do it a little bit smaller, but is there something that they have in common that we can divide by? So it looks like you can divide 2, 16, and 66. They're all divisible by 2. The first term is negative, so I'm going to make sure and say we're going to divide by negative 2. How many x's do they have in common? well, it looks like they all have at least two x's, right? X squared. So that's going to be what I'm going to divide all of these by. I'm going to divide them all by the GCF of negative 2x squared. So remember, we usually set up a parentheses and put the GCF in the front. Okay, and then we divide. Negative 2 divided by negative 2 is 1. X to the fourth divided by x squared is x squared. 16 divided by negative 2 is negative 8x. And 66 divided by negative 2 is negative 33. And then x squared divided by x squared will cancel. All right, and then we got to check, is what I got left over, is this a special situation, or is it something that we've seen before? So it might be a perfect square trinomial, but the question is, can I square root the last one? Well, it's negative 33. Well, I can't square root a negative, and I can't even square root 33, right? So before we say that it's prime, let's see, can we check the method that we did last class, where we did the table, right? So let's do that table, and on the left we were multiplying, and on the right we were adding. Extend this line over here. And so this is in front of x squared. If there's no number, we assume that there's a 1 there. And so we're going to multiply the first number times the last number. So that's 1 times negative 33 is negative 33. And then what is 1 plus negative 33? That's negative 32. But the middle number that I want is negative 8, so that doesn't work. So we try different numbers, but what's the next number? 33 and 1 doesn't work. What about 3 times 11? 3 times 11, and if it's negative 11 and positive 3, that gives me negative 33. And what's negative 11 plus 3? It's negative 8. Awesome, so I get everything that I want to get, right? Multiply and I add to get the middle. So that means that I can, sorry, I keep forgetting to change it back to black. This means that this equals 2. Remember, I'm going to bring the GCF over to my answer. Negative 2x squared was my GCF. And then I'm going to make sure to put 2 parentheses here, right? And the variable is x. So x and x. What was the combination that worked? It was negative 11 and plus 3. So one of them is going to have negative 11, and the other one's going to have plus 3, and so this is my answer. All right. Let's go to number 3. So again, check for GCF. Well, looks like they don't have any m's in common, right? But can both of these numbers be divided by the same common number, greatest common factor? And it looks like they can both be divided by 3. So that's my GCF. I'm going to divide by 3. And so I'm going to set up my parentheses. 12 divided by 3 is 4 with an m squared minus, what's 27 divided by 3? It's 9. And so again, we got to check, is what's in parentheses, is that a special situation? And it looks like it might be a difference of squares. So we got to check, is there subtraction happening? Yes. Then we got to check, can I square root the first and the last? Yeah, I can square root 9 and I get 3. Square root of 4 is 2. Square root of m squared is m. So I can square root that one as well. So everything checks off here. This is a, let me pick a color here. This is, so what we're saying is that this is a difference of squares. And so for a difference of squares, if this is my a, and this is my b, a difference of squares is a plus b times a minus b. Okay, so remember, I'm going to bring over the GCF over to my answer. So this equals to 3 times a plus b times a minus b. So a plus b is going to be 2m plus 3. And 2m minus 3. So that's my answer. Okay, so again, make sure that you bring over the GCF. And then we said that this part that I underlined in orange is a difference of squares, and so we use the rule for the difference of squares to get these two parentheses. Okay. And then let's go to the last page. Okay. So again, check to see. And let me zoom in a little bit. Check to see if we have a GCF. And it looks like they don't have any numbers in common, but they do have letters. They have at least one y in common. So I'm going to divide all these by y. And so that means I'm going to have y parentheses and then divide, right? So y to the third divided by y is y squared plus 11. Y squared divided by y is y minus 24. And the y's cancel here. Okay. So then we got to check this parentheses that was left over. Is this a special situation? Is this like a table situation? Well, if it was a perfect square, that means I could square root the last one. But I can't square root a negative number, and I can't square root 24 and get a whole number. So then let's try the table method. And let me just change some colors here. But we're going to do the table method. And so we're going to multiply on the left and add on the right. And again, in front of y squared, if there's no number in front, we assume it's a 1. So we're going to check what's the first number times the last number. And so what is 1 times negative 24? That's negative 24. But 1 plus negative 24 is negative 23. Okay. So that doesn't work. But think about, oh, sorry. It doesn't work because I want to get positive 11 when I add, right? So I don't want to get negative 23. I want to get positive 11. So think about numbers that multiply to give you 24. 2 times 12, but 2 minus 12 is 10. What other numbers? 3 times 8. But I want to get a negative 24, right? So that means, like, let's just try that out. Let's try 3 times 8. Because isn't 3 plus 8 11? Okay, 3 times negative 8 is negative 24. But 3 plus negative 8 is negative 5. Nope. And 2 times 12 doesn't work. Yeah, we checked 2 times 12. What about 6 times 4? 6 times negative 4 is negative 24. But 6 plus negative 4 is 2. Also doesn't work. So if we keep trying it, we won't get a combo that will give us 11. So that means that the most that we can do is just factor out this y that we already did. So my final answer is what I got after I divided by y. So after I divided by y and I factored that y, then I couldn't do anything else with the parentheses. So that means that's my answer. And keep in mind, it's not a prime answer because we were able to take out the y in the very beginning. So if we're able to factor out something, it's not prime. It's when we're given a problem and we can't do anything with it, then it would be considered prime. Okay, let's go to example 5, and then we'll do the word problem at the end. Okay, so example 5, it has 3 terms. I don't think it has a GCF. Let's see. Do they all have an n? No. Remember that there's a 1 in front of the n squared. So can I divide all of these by the same number, by a GCF number? Nope. So they have a GCF of 1. but it might be a special situation. But look at the last term, it's a negative. I can't square root a negative. Okay, so it might be the table method. We can try that out. Extend this. And so we're going to multiply on the left and add on the right. And so we're going to multiply 1 times negative 16. That's going to give me negative 16. But 1 plus negative 16 is negative 15. That's not the middle number that I want. I want a positive 8. You could try, no, 2 times negative 8. Looks like it won't work. 2 plus negative 8 is negative 6. But I don't want a 6, I want an 8. What about 4 times 4? Isn't 4 plus 4 8? But I want to make sure that the 16 is negative, right? So that means that one 4 has to be a positive and the other one a negative. So if I have that situation, what's 4 plus negative 4? That's 0. Nope, it doesn't work either. So it looks like I've tried all the possibilities of multiplication to get negative 16. And none of them seem to work. So I have a GCF of 1, which is nothing. I have nothing that works in the table. And it's not a perfect square because the last term is negative. So in this case, this would be a prime. And actually I don't need the equal sign here, but it would just be called prime. Okay, let's go to example 6. So example 6 says that this equation is the area of a square. Okay, and then it gives us a formula from geometry, and it says find the length of the side in terms of x by factoring. So they're telling me in the beginning that x squared minus 24x plus 144 is the area. So can I factor this? In other words, is this a perfect square trinomial? Well, we got to check. Can I square root a couple of things? Can I square root the first term and the last term? Positive. Square root of x squared is x. So yeah. The square root of 144 is 12. So yes. And then we got to check what's 2 times a times b. It's 2 times x times 12. Right, because this is my a, this is my b. 2 times x times 12 is 24x. And so that matches, right? So everything checks off. So we have a perfect square. We just got to ask ourselves, do we have a plus plus or a minus plus? If we have a minus plus, that means that the factor is going to be a minus b times a minus b. And so it's going to be x minus 12 times x minus 12. So remember, in a square, both sides are the same length, right? And remember that we can write this x minus 12, we can write it in the following way. Right? Area is equal to x minus 12 to the second power. So then what is S? S, which is the length of the side, is just one side. Right? If this is x minus 12, this is x minus 12. So it's just saying, if one side is x minus 12 and the other side is x minus 12, then the length of one side is just x minus 12. Right. Okay. And so then part B is asking you to find the perimeter. So they gave us the formula for the perimeter from geometry. And so it's going to be P equals 4 times S. But I already know that S from part A is x minus 12. And so what should I do with the 4 in front of the parentheses? I should distribute, right? So if I distribute, I get 4 times x is 4x, and 4 times negative 12 is negative 48. So this is my perimeter. Which brings us to the end of the notes. Thank you for joining me, guys. And as always, I'm going to be open to answer any questions you may have next class. And so I'll see you guys then. And have a good remainder of your day. See you guys.